Welcome to another tutorial of ProfLearn YouTube channel. In this particular video, we're going to talk about errors, and we're going to look at different type of errors and how those errors can be corrected. This is the series of AS Physics, so we are going to pick from where we left, and something that you're going to appreciate is that you are going to learn skills sets, and you're going to see how different ways you can be able to approach different questions in this case. Now, one of the type of error that we are going to talk about is the error that we call systematic error. These are types of error which are consistent, which are repeatable, and also predictable. So examples of sources of systematic errors include zero error. We can talk of wrong calibration and also environmental factors. So you're gonna realize that all the values, all the measurements that are taken are usually shifted by the same amount. So for instance, if you draw a graph from a kind of data that is obtained where it has systematic error, you realize that if this point was supposed to be able to be shifted some value up, this one also will be shifted the same value up. For instance, you realize that all the values are shifted to in a particular direction, and that is now what is called systematic error. So you realize that the gradient of the line, yes, will be the same, but the intercept will be what? Will be different. So you realize that this should have been the expected results, but due to that systematic error, we are going to get this line of best fit. So we're going to realize also, whenever we are going to discuss, as we continue discussing this, we'll see that finding average does not really affect what you can have. Now, effect of systematic error, it reduces accuracy. It reduces the accuracy in the sense that the measurements shift or move away from the true value. So when the measurements that you take are different from the true value, we say there is less accuracy. So in that case here, a systematic error affects the accuracy of the measurement and cannot be corrected by finding average because all the values are shifted in the same amount. Now, the next part we are going to look at, how do you really minimize? How can you be able to minimize the systematic error? Because all the values are affected, and we say that the causes of this systematic error is zero error, wrong calibration of the instrument, and also environmental factors. Then in order to correct this type of error, what you need to do is to correct these causes. And to do that, before you take a measurement, the first thing that you have to check is is the zero error corrected? Yeah, if maybe you are using a vernier caliper or you are using a micrometer screw gauge. If you close the instrument without any object with the zero scales coincide, so whenever you want to correct or minimize systematic error before you take any measurement, ensure that you have checked the zero error before taking a measurement. Number two is to ensure that the instrument is well calibrated, and also use better equipment, because if you find an instrument is faulty, it may affect the measurement. So if you want to correct that and you realize there is a mistake, just use a better equipment and also control environmental factors which are maybe contributing for the shift of the measurements in a particular direction. Now, after talking about systematic error, and we have said that it is predictable, yeah, we need to talk about another type of error, and this error that we're going to talk about is called random error. Random errors are unpredictable fluctuations when you are taking a measurement. Random error is different from systematic because it's unpredictable fluctuation while you take a measurement. So you cannot be able to predict. You cannot be able to tell this error is going to occur unless otherwise you are the cause of it. Now, causes of this type of error include human error while taking the measurement. So for instance, if you are taking a measurement and you read wrongly, you position your eye wrongly while taking the measurement for this case here, then you are going to cause what we call random error. Environmental variation, for instance, if you are maybe measuring temperature, if you are measuring temperature and you realize that the temperature of the surrounding, maybe now it becomes more sunny, yeah, temperature of the water will rise, isn't it? Or if you are taking temperature and then all of a sudden a lot of wind blows, then a lot of evaporation will take place, and that is going to affect the temperature that you are going to record. So environmental variations, and also instrument limitations, because we can talk of sensitivity of different instruments. If sensitivity of an instrument may vary. For instance, if maybe you are measuring voltage, you may find that the pointer will keep on moving, it will not settle down, then you may take a reading which is not correct, and that is gonna result what we call random error. So when you are talking of random error is going to be distributed around the true values, So this random error affect the precision. Remember, precision is determined by how close the measurements are. For instance, random error can cause you to take a reading 3.46, 4.46, 6.38. These values or this measurement that we have here are not precise because they have a very huge range from each other. So which means that they are not precise. Then if maybe you draw a graph and draw a line of best fit, the line of best fit may tend to try to correct maybe those errors that we are talking about. One way of which you can be able to determine to identify a random error is how the measurements vary from each other. If measurements are quite far from each other, it means that causes what? Random error. So you see, if we are having random, they are going to have uniform distribution from the true value. Yeah, they will be distributed in either side, and if you plot a graph, you are going to correct that by a line of best fit. So the reason as to why we usually draw graphs is to ensure that we can be able maybe to identify different errors that were introduced in the process of what? Taking the measurement, right? So lines of best fit reduces random error, but when we are talking of systematic error, line of best fit cannot solve that problem, because all the values are shifted in one side, so you are going to get a very different line of best fit. Yeah, so that is quite important and key at this point. Now, how do we minimize random error now? You take multiple measurements and find the average. But for systematic error, you cannot be able to take multiple measurements and then divide or find average, because all the measurements are shifted by the same value in a particular direction. So even if you do average, you are not going to correct that error. But for random error, take more measurements. By taking more measurements, you will be able to realize there is a value that is a bit inconsistent with the rest, and then you working out the mean. It's actually another way of reducing that. Also, while taking the readings, you have to be very keen. While taking the readings, you have to be very keen so that you don't really make a mistake, because random error can also be contributed by human error. So one way to correct that, take readings carefully. And for instance, if maybe you are taking the level of water in a beaker, you have to read below the meniscus, and you have to position your eye properly so that you can be able to take that particular measurement. Maybe you can also correct that by collecting the data, plotting the graph, and then drawing line of best fit. That is going to correct the error. So basically that is what you need to understand as far as systematic error is concerned. So you need to understand the definition of each of them, and then also you need to know how you can be able to correct those type of errors. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. You can see these papers I'm having here, guys. These ones I'm having here. I'm going to take them and I'll upload them in our Patreon page so that you can be able to get them right from my desk here. I'm going to send these papers to you. So just check in the description. I'll add a link that is going to take you straight to my Patreon page so that you can be able to access the PDF that you can see I'm having here. So you can see these papers I did here. I want to send them to you, so just check in the description. You get the link that's taking you straight there. See you guys.